So let's start with carbon present, carbon future. This is a quote from Hugo Gernsback from the Scientific Adventures of Barry Munchausen from 1917. From 1917, way back when, right? More than a century now. These atmospheric cleaning plants are erected in sufficient number over the face of the planet in such an ingenious manner that all of the air must flow sooner or later through one of these wire cubes here to be purified. Thus does Martian intelligence safeguard the planet's air supply. How long will it be with your coal-burning machinery till the Earth's atmosphere will need cleaning plants? Okay, imagine this was after Svante Arrhenius figured out carbonic acid and its impacts, but he was excited about it, saying maybe we will avoid ice ages and will have equitable weather for all for a long time, and before Guy Callendar in 1937, who also did detailed calculations of warming based on all the data he could find of coal burning and atmospheric CO2 and so on. What is the issue we are dealing with in terms of carbon present? Of course, when it comes to sequestering carbon after capturing it, the main thing to start with is to look at atmospheric composition. 78% is nitrogen and almost 21% is oxygen, and the remaining little sliver is almost all taken up by argon, with a tiny bit of room left for hydrogen, krypton, neon, helium, methane, and then you have CO2, which is 0.0407%. So anything reasonable in terms of amount of CO2 that you want to directly take out of the air has to have a massive amount of air flowing through it. The energy and the heat needed is just prohibitive, at least in terms of cost per ton of CO2 you can extract, and of course you have to worry about whether when you're done you're going to be actually carbon neutral in terms of the amount of energy you spent to draw down the carbon, right? We are here in terms of orienting ourselves, putting out CO2 increasing now at about 4 ppm per year, so we have blown past 410, now almost 420 by 2021. The COVID lockdowns had reduced the emissions, but now we are back to normal, so we are still on this emissions for business as usual trajectories in the IPCC scenarios. Nonetheless, the efforts continue for direct air capture. This is a rendering of the carbon engineers large-scale carbon dioxide removal plant, which will use direct air capture. So you can imagine air flowing through this, and there is some scrubber which will draw CO2 out of the air, and then that CO2 is somehow re-released into pure CO2 and converted into either fuel or used for forcing out more fossil fuels, or some other use into plastics and so on and so forth. But you can imagine just how much air flow through is required, considering the tiny percentage of CO2 in the atmosphere. More attractive options are offered by people like Klaus Lackner, who's now at Arizona State, or one of those universities in Arizona. So this is showing strips made from anionic exchange resins, chemically absorbing carbon dioxide when dry and releasing it when wet. Such strips can be used to draw CO2 from the atmosphere. So looks almost like a plant, right? And here it is, an artistic rendition. Right now they are way too big in terms of the flow through required and the amount of CO2 they can take out, but there is lots of effort underway over some time now to make them smaller and more efficient in terms of the amount of CO2 they can draw down. To remind ourselves of the future of carbon, how do we want to keep global warming below 1.5? This is the trajectory we are on, path under current climate protection, remaining carbon budget in terms of where we have to be if we want to hit 1.5 degrees C by 2100 with a reasonable probability like 66%, then we should have already started going down in terms of emissions in global CO2, gigaton CO2 per year. Obviously we are not doing that yet. So the traditional mitigation technologies have all been considered, and this is just not going to happen without carbon removal. So it's a question of whether geoengineering is safe or not, but when it comes to carbon capture and storage, carbon capture and sequestration, carbon capture and utilization, and various other words used for this process, there is going to be a need to draw down CO2. So it's not like we will emit negative amounts, it's that there are some inevitable emissions, and then we will have to take out more than we emitted. We will see that actually the amount of warming is not just going to be about the pulse of CO2 we are putting in. So even if we have the emissions, we are going to keep adding to the accumulation that's happening since industrial revolution, and this is what gives us the warming. So reducing emissions is not going to solve anything. We literally have to go below zero in terms of taking out CO2 that's already there. Okay, in addition to taking out what we will be emitting for a while. So these are the basic ideas. This is from this paper. We will see more figures. So ambient air is flowing through. There is a some kind of a scavenger or a scrubber which removes CO2. So CO2 is chemically bound to this filter, and then CO2 free air is let out. And in phase 2, once the filter is saturated with CO2, the filter is heated to 100 degrees centigrade, and then concentrated pure CO2 is prepared for ways to deal with it. CO2 is then released from the filter and collected. There are several methods of doing this. This is one particular approach by Climeworks. So it has its plans to take in ambient air, create CO2 free air, and the required heat is planned to be obtained from geothermal power plant. Demonstration units are there, but the total amount of CO2 being drawn down right now is ridiculously small, nowhere near the amounts we will need to draw down to hit any of the temperature targets. So concentrated CO2 with water is turned into carbonate minerals. That's the plan, and go together with the underground basaltic rock formations. Again, how much can go in there, how long it'll stay, whether it has earthquake hazards, and so on and so forth, all have to be still completely assured. Here it is in terms of the total system. CO2 is captured directly from ambient air using renewable energy. This is important because it requires some energy, plenty of energy and heat. CO2 free air is produced. There is renewable energy. Electrolysis, so water supply and heat recovery is done. Hydrogen and oxygen are produced. Concentrated CO2, reverse water gas shift, synthetic gas is produced, which is kind of an intermediate fuel, and using what is called Fischer-Tropsch process, there are hydrocarbon fuels planned to be produced. So syngas is turned into hydrocarbon fuels. Because the CO2 has been captured from the atmosphere, the produced fuels are carbon neutral. Okay, but the caveat, of course, from International Energy Agency is that there are currently 15 direct air capture plants operating worldwide, capturing more than 9,000 tons of CO2 per year, with a 1 million ton CO2 per year capture plant in advanced development in the United States. In the solid this method, direct air capture is scaled up to capture almost 10 million tons of CO2 per year by 2030. This is within reach, but will require several more large-scale demonstrations to refine the technology and reduce capture costs. Okay. Sorry, here SDS is the Sustainable Development Scenario that figures out how much CO2 is required to be drawn in order to meet our goals by 2030. Okay, so this is the story of direct air capture. Now we will go to other methods of altering the chemistry in the ocean, maybe trying to put it on land, and maybe fertilizing the ocean, modifying the ecosystem to take up more carbon dioxide into the ocean. So we are talking now geoengineering to alter the ecosystem, not as an unintended consequence, but an intended direct manipulation of the ecosystem.